Lesson 4 activities. Number 1, use a straight edge to draw some things on the graph of f at right, and then estimate the derivative of, that's a typo, that should say f, at x equals 0 and x equals -1. Okay, so we know that f prime of 0 means the slope of the tangent line at x equals 0. So we put a dot right there at x equals 0, and then we're going to ballpark a tangent line. We're just going to draw a tangent line. Use a straight edge. I'm freehanding it here, but use a straight edge, something like that. And then we're going to estimate the slope of that line by picking 2 points that are roughly on the line. You could pick the blue point that's highlighted there, but you don't need to. So we'll pick that point there, and maybe, I don't know, this point up here looks like it's something around 3, 4. And this is roughly 0, 1, and so we're just doing the slope of that line, change in y over change in x, 4 minus 1 over 3 minus 0, 3 over 3, which is 1. So f prime of 0 is 1. Slope of the tangent line at 0 is 1. Now we're going to find the derivative at -1. Same idea, but now we're focusing our attention at x equals -1. So on the curve, it's right there. And then we're drawing a tangent line at that spot. Again, use a straight edge. I'm freehanding here. So you want your tangent line to just barely graze the curve at x equals -1 and then not again. And then we're going to try to find 2 points that are roughly on that tangent line. And I'm looking for points that have coordinates that are easy to read. I guess I'm going to pick this point right here. It's getting kind of cluttered, but that looks like the point 1, 1 is pretty close to being on my tangent line. And if I extend my tangent line just a little bit, I'm going to go ahead and say that -5, -1 is on there. So it's fine to use the x equals -1 as one of your points, but you don't need to. Any 2 points that are on the tangent line are good enough. Okay, and so in this case, again, change in y over change in x. So 1 minus -1 over 1 minus -5. So 2 over 6, or 1/3 for the slope of that line. Makes sense. It's uphill, so it's going to be a positive slope, but it's not too steep. So 1/3 is reasonable. Number 2, same deal, f prime of 0. So now we're going to go to the point where x equals 0, right there. And you're going to draw the tangent line. And the tangent line here is kind of wonky in that it goes through the curve. Like it's under the curve there, and then it's over the curve. And it's okay for the tangent line not to be entirely above the curve or entirely below the curve. And so we're, again, estimating the slope of that line. I'm just counting boxes. I can see that it looks like f prime of 1 is rough. F prime of 0 is, sure looks like it's 1. Okay, let's do the next one, f prime of 2.4. So we go to 2.4, roughly here, and then we go up to the curve, and then we draw a tangent line. So this one is going to be downhill, probably not quite as steep as the blue line is uphill. And then again, we're just picking points. I'm going to grab this one here. It looks like that's at 1, 2, and then maybe this last one that I drew here, -2, 4. Again, there's a range of acceptable full credit answers here, even though we're not all going to get the same thing. We're estimating, but we should get numbers close to each other. So change in y over change in x, 2 over -3, or -2/3. That negative is reasonable. This one's going downhill, but again, not quite as steep as the uphill line, which we saw had a slope of 1. Okay, last one, f prime of -π/2. So -π/2 is the first minimum that's negative. There's -π/2 right there. So you should know that on this, actually maybe you shouldn't know anything because I didn't say what this curve was, but I'm pretty sure it's a sine graph. But anyway, -π/2, if it's indeed the bottom point, then we should be able to figure out the derivative without any calculations. F prime of -π/2 is the slope of that horizontal line, and the slope of any horizontal line is 0. Okay, so I can demonstrate this just a little bit on Sketchpad, so we'll do that now. So the first thing we calculated was f prime of 0. So there's the function. I didn't tell you before officially that it was signed, but it was. And so I'm at my special point right here. It happens right now at x is about 4. And the slope of this particular line, which is the tangent line, is around negative 0.6. And for every single point that I move to, the tangent line just follows all the way around, and I'll just move it to x equals 0 right there. And so at x equals 0, the slope of that tangent line is 1. There it is. And then we went over to 2.4. So 2.4, the sketchpad is saying negative 0.74. That's going to be more accurate than our answer. What did I get? I got negative 2/3, which is negative 0.6 repeating. Close enough. Like I said, there's a range of acceptable full credit answers. And then finally at negative pi over 2, so negative pi over 2 is around negative 1.57. And so if we get to roughly negative 1.57, then we should have a tangent line that's horizontal or flat, so very close to 0. I'm not quite at negative pi over 2. That's why it's not exactly 0. Okay, number 4, this one's from your book. Instantaneous rate of change of x ln of x at a equals 5. We're going to make a table of values, but first we're going to touch some stuff. So, or we're going to write some stuff before we touch the calculator. Okay, so the definition of the instantaneous rate of change. Here we go. Rate of change instantaneous is equal to, all right, leave some space because there's going to be a limit that goes in there. I know that the definition is f of a plus h minus f of a all divided by h. So anything with an h in it we can write. And even the part in the front, which is a limit, we can write that too because that's always h, always going to 0. And so the only unknown are the two things that are blank right now, and that's the value of a, which in this case is 5. So it's 5 plus h and 5. Okay, so tiny bit of calculating, and then it's really no work at all here. And then we'll use the graphing calculator to get a table of values. So f of 5 plus h, what does it mean? It means that every single one of these x's is about to become a 5 plus h. So the first x becomes a 5 plus h, it needs parentheses now, times ln of the second x also becomes 5 plus h, minus, and then f of 5, now both of those yellow highlighted x's become 5s. So it's just 5 ln of 5, all divided by h. Now we're just going to use the calculator and we're just going to make a table of values. We actually don't have any techniques to do the algebra, like exact way to do this, so a table of values or a graph of the function is pretty much all we can do at this stage. But soon enough we'll have algebraic shortcuts, rules that will allow us to take a derivative of that without relying on the calculator at all. Okay, so what I'm typing in is this thing right here. I'm going to be fancy and put that whole thing into my y equals menu. Open parentheses for the entire numerator, and then 5 plus h needs its own parentheses. So 5 plus x, ln of 5 plus x, close that, minus 5 ln of 5, close the ln, close the numerator, all divided by not h, but x. And then if I go into table set and we change it to ask, then I can type in particular values of h. It's always h going to 0 for the derivative. So for example, 0.1 and 0.01 and 0.001. I can try putting 0 in, but it's going to give me an error every time I do a difference quotient. But then we should also do some negatives. Okay, and I'm looking at these numbers here. Looks like 2.60 something, 09, 2.609. I guess it's probably someplace between this number and this number. So we'll just call it, I don't know, 2.6094. So roughly 2.6094. That is from the table. And I'll go ahead and make a screenshot of that for this document. Okay, so there's our screenshot, which is where we got our estimate from. Okay, next one, same deal, but the function is 1 over x squared, and now we're going at x equals 2. So we're going to copy the same formula here, just these 5s are going to become 2s. Okay, now we're doing f of 2 plus h. So this is the function 1 over x squared, but instead of x, we have a 2 plus h. It now needs parentheses, and it is getting squared. Minus, and now f of 2, that's just 1 over 2 squared, and then the whole thing is divided by h. And so I'm just going to type that thing very carefully into the calculator. We're going to do some fraction algebra on the next page, but for right now, I'll bail out and use this thing. Okay, so being very careful with parentheses. Open parentheses for the entire big numerator, which has 2 fractions in it. Okay, so then I do 1 divided by open parentheses 2 plus x, whole thing there squared. That's my first fraction, minus 1 divided by 2 squared is 4. Then I close the top whole thing, and then I divide it by x. Now the nice thing about doing these back to back is that exactly the same values of h are still good here because we're still sending h to 0. So our best guess is something that we're looking at over here. It looks like these numbers are heading to like negative 0.25 maybe, something in between this one and this one. So that's our guess from the table. I'll make a screenshot as well. Okay, so our guess from the table, something around negative 0.25. Okay, next page. Use algebra to calculate the exact value of this derivative. So we're starting it exactly the way that we did before. So it's, I'll just use this notation this time. F prime of 2 equals limit as h goes to 0 of all the stuff that we wrote on the previous page. So that was a 1 over 2 plus h squared minus 1 over 2 squared, the whole thing divided by h. But we're not going to bail out and use the table here. We're going to do some serious algebra to see if we can get to a point where we can just plug in h equals 0. Now we can't just plug in h equals 0 at the moment because we'd have division by 0 here, which is not the end of the world, but then you plug 0 for this guy, and this whole thing is just 2, and therefore this is just 2 squared, and 1/4 minus 1/4 is 0, and so we get 0 divided by 0, which means we can't just plug in. So let's do some algebra here. Limit h goes to 0 over h, the whole thing over h. So I'm going to get a common denominator on top. So this entire thing right here, we're going to make one single fraction, and the lowest common denominator up there is the 2 plus h squared, and then also the 2 squared. I'm just going to put a 4 for that one. Okay, that is the lowest common denominator. This first fraction, we're going to multiply by a 4 on the bottom and therefore a 4 on the top. And the second fraction, we're going to multiply by a 2 plus h squared on the bottom and therefore a 2 plus h squared on the top. So that gives me a 4 minus 2 plus h squared, putting those fractions together into 1. So take your time with that. Make sure you're comfortable with the algebra of fractions, lowest common denominator in this case. Okay, still more work to do up on the top. We do have to copy this limit every time until we actually get to a point where we plug in h equals 0. 4 minus, okay, 2 plus h squared, that's a FOIL, write 2 plus h next to itself twice. 4 plus 4h plus h squared. Common wrong answer is 4 plus h squared. I'm going to copy that denominator. No need to distribute or FOIL down here. And then the whole thing is still divided by h. Make sure your fraction lines are different sized so you can tell which part is which. Okay, and now good things are finally going to start happening. So this 4 subtract that 4 cancels, and then the negative comes in and distributes through what's left. So I see a negative 4h minus h squared divided by 2 plus h squared times 4. Now here's the other thing. I'm tired of writing this over h, and so I'm going to tell you that either the h is actually up here, h times all of that, or it's down here, h times all of that. Only one of those is right. Hopefully you can figure out where this h goes. It goes on the bottom. If you want to really see the details, multiply down here by 1 over h, and therefore up here by 1 over h, top and bottom of the big fraction by the same thing. And then the h's cancel here, and you can see the h is left on the bottom, which is where I put it. Okay, we are going to factor an h out on top, and hopefully it's now starting to look familiar because this technique hinges on being able to factor h out on top. Not LCD, just h. Okay, and then the best part of this problem is right here, canceling those h's. This is again why we don't distribute on the bottom. We like the bottom in factored form. Okay, so I'm just going to write the limit one last time and then copy what remains. And now we're going to try plugging h equals 0 in again because we have a brand new limit. And that canceling that we just did in blue is going to get rid of the problem that we had with trying to plug h equals 0 in at any earlier stage in this problem. So don't write the limit, but just change all of the h's to zeros. Upstairs, I see -4. Downstairs, 2 squared is 4 times 4. Cancel one of those 4s, I get -1/4, which was exactly what we guessed from looking at the table of values. So number 7 is our summary. We found f prime of 2 numerically. That was with the table of values. So numerically means with a table. And then we just found the exact value of f prime of 2 algebraically. That's the hardcore algebra, some algebra technique. In this case, it was a common denominator and eventually getting rid of the h that was in the bottom. And then there is a third option, which we didn't do on this problem, but if we looked at a graph of 1 over x squared and we drew a tangent line at x equals 2, we could estimate the slope of that tangent line and therefore estimate f prime of 2, and that would be called graphically. So you should know how to estimate derivatives numerically and graphically, and then calculate exact values algebraically.